So the next theorem is theorem 10. It is that chords equal in length are equal distance from the center. So we want to show that OD and OC here are equal distance, so equal length. So we're given that MN, so our chord MN and PR are equal length, and we know that MDO and PCO are going to equal 90 degrees. So to prove this, we want to say that, like I said, this and this are equal in length, and we're going to construct OM and OP to the center so that we have some radii to work with and two triangles are formed. So our proof is again going to be two congruent triangles. So we have in here, we know that MN and P are equal. We also know because of theorem, theorem 8, that our chord, or theorem 9. Yes, it's theorem 9. So our chord that's bisected by a radii, so AO is a radii, will be bisected. So MD and ND are the same length. So MD is equal to ND. That's because of theorem 9, which looks like this code. We also know that by the same logic that this and this are equal. So PC is equal to RC. Same theorem. And if that's true, and we know that MN is equal to PR, therefore MD is equal to PC. And that helps us with these two congruent triangles. So now we have two sides in common. We also have radii, so MO is equal to PO because they're radii of the same circle. Radii of same circle. Now we have two side lengths and we also have a right angle in there. So my right angle is MDO is equal to angle PCO, and that's a given. So I should also say that they're both equal to 90 degrees. So I've got two sides. My radii are a hypotenuse and a right angle, so I can say RHS. So therefore, triangle MDO is congruent to triangle PCO RHS. If they're both congruent, then this bottom side of my triangles must be equal to each other. So this and this must be equal. Therefore, DO equals CO. And that's it for that proof. Done.